Hello, today we're going to talk about 2.7, which is absolute value functions. So the first one, I split this into 2 days. The first part is just talking about graphing, so just getting the graphs. And we can graph anything, okay, by just making a table. So let's just do that. So I start by plugging in anything. And you can see my graph here that I made goes from -5 to 5. So why don't we plug in some x values in between there, like for instance, let's plug in 5, and how about 3, 1, 0, -3, -5, okay? I picked random values, it does not matter, okay? So we plug in 5. Well, the absolute value of 5 is just 5. Plug in 3. The absolute value of 3 is 3. Plug in 1 for x. You get 1, plug in 0, 0. Now here's where it gets interesting. The absolute value of -3 is just +3. The absolute value of -5 is just +5. So we go over here and we graph them. We plug our points in, and we can start to see something. Now here we start to get this nice line. Alright, so don't be fooled, don't be tempted to just continue that and make a single line. Because if it was a single line, it wouldn't have absolute value bars, right? If it was a single line, it would be written something like y equals mx plus b. Alright, so that's linear. Okay, what I want you to get from this lesson is that this is absolute value when we have the bars. Okay? So when we get to the other side, notice something starts to change. It's not linear. It appears more like a V. And that's exactly what it is. Think of it like two lines, all right, meeting up at one point. Okay? So this is what you should expect to see on every time you see absolute value. All right, it's going to look like this. All right, oh, I guess I should clarify. This is called the parent function, all right? It's the original function. There's no other numbers. We're not adding, we're not multiplying. It's just the equation, just y equals the absolute value of x, okay? So here we've got a negative outside. So let's do the same thing. I'm going to make a table. Sorry, I didn't like how I wrote that. Alright, so I'm just going to start with some random things again. Let's plug in 5, because that's the furthest right spot. So we plug that in. The absolute value of 5, so again we're doing the absolute value of 5 is 5, but then we have a negative out front. So we end up with -5. Then we plug in, let's plug in 3. Alright, negative absolute value of 3 is just -3. Alright, we plug in 0. That's kind of nice to see. Alright. Plug in, let's do -2. Alright, negative absolute value of -2. Well, absolute value is just 2, but then we have a negative out front. So -2. Plug in -4. Negative absolute value of -4 is -4. So here we can start to see the change. Oh, I did a +5, just kidding. Down here, 3, -3, 0, 0, 2, no, I'm sorry, -2, -2, -4, -4. Okay. Well, I did something wrong. Oh, I did this one wrong. That point looked funky. Alright, so I can start to see that I'm going to continue it. This line is going to keep going this direction. This line is going to keep going in this direction. And I can see, well, that doesn't really make sense. Those right here doesn't make sense, because we took our points here and we're going from this point to this point to this point and now back. Again, we can double check it by plugging in more points. -1 is -1. Plugging in 1, we also get -1. So we get those points as well. All right, so if we have a negative out front, it now makes it an upside down V. Okay, so now it's going down. All right, so what if we put a number on the inside of our absolute value? All right, again, just like anything else, let's plug in some stuff. All right, I'm just going to go, let's see, 2, 1, 0, -1, -2, just so I can get some positive and negatives and just see what happens. If you plug in 2, you should get 4. Plug in 1, plug in 0, -1, -2. Okay, so I've got a lot of points here. So if I plug these in, well, I've got a problem. It's all linear. We don't see the change, okay? That's a problem because these are absolute value bars, so I should have some kind of V, right? I told you about that. So this doesn't include my changing point, so let's keep going. Why don't we plug in -3? Here we go. Plug in -4, -5. So now we start to get the turning point. I'm sorry, -4, 2, -5, 3. There we go. So we include our lines and we draw our arrows. All right. So now that we've got our graph here, one key thing to notice is we didn't start getting the V until, notice our Y values. There's a pattern, okay? Notice our turning point was right here. The corner of our V is at -2, 0. And then look at our Y values. They start to repeat. So that's a hint on what you are knowing on whether or not you've got enough points. Okay, so here, why don't we try graphing this one, make a table, and see if you can get enough points so you can start to see that turning point. Okay, I'll let you pause it now. All right, so you should have gotten these values or something along those lines, all right, but the turning point was at 4, 0. Okay, so let's try some more. What if I put a value on the outside? Okay, so again, I'm just going to make a table, and if I don't know what to plug in, then I'm just going to pick things around 0. So 2, 1, 0, -1, -2. So if I plug in 2, plug in 1, 0, -1, -2. Again, I'm just plugging those x values into my equation over here. And here, I know I'm doing all right because I've got some y's that repeat, okay, that repeat in this form. So let's graph it. So 2, 5, 1, 4, 0, 3, -1, 4, -2, 5. There we go. All right, now do number 6. Again, make a table, graph it, pause, and then I'll unpause in just a second, so do that. All right, so this is what I got for number 6. All right, I got this on my table, and I've got my graph here. All right, let's keep going. Number 7 and number 8. So again, graph these two the same way you did the other ones. I would make a table, and since we haven't learned any tricks yet, I'm just going to start with these values. Okay, so take a minute, pause this, and come up with your tables and your graphs for these. Okay, so these are the graphs that I got. Hopefully you got the same things. Notice for number 8, I added 2 extra x values just because they ended up giving me nice y values. You don't have to do that. You can use this decimal. Just know that when you graph 1, 0.5, you're doing a rough estimate. Okay? But again, you can plug in 4 instead, so you don't have to graph decimals. Okay, and that's just kind of playing with the numbers. All right, so let's look at all of our graphs together and start comparing them. So the first thing we did is we graphed the parent function. Then what we did over here for numbers 3 and 4 is we added a number or subtracted a number. Well, notice when I added the number, I went to the left. Oh, well, left how much? We went left 2. And notice when I subtracted 4, my parent function shifted to the right 4. Okay, so when we add or subtract, we're moving left or right along our x-axis. And that makes sense because we're directly affecting x. Okay, but you kind of have to think about, you do the opposite of what you want. Okay, because when we're adding 2, we're going to the left. When we're subtracting 4, we're going to the right. Okay? Now let's look at numbers 5 and 6. So again, here we have our parent function. And here we are adding or subtracting on the outside. So notice when I added, my parent function went up 3. Then when I'm subtracting 5, my parent function shifted down 5. Alright, so when we have a number on the outside, we're going up and down the y-axis. Okay, and since it's not right next to the y, alright, it's on the other side of the equal sign, we're going to keep it the same. So when we add here, we go up. When we subtract, we go down. Okay, so these are little ways to help us do things. Okay, the last thing we did was we put a number on the outside in front of it. Okay, so here we have our parent function, and for these we have a number on the outside. Okay, so let me see. When we multiplied it by 2, notice what happened. It got skinnier. Okay, notice when I multiplied by 1/2, my graph appears much wider, much fatter. Okay, so what I like to do is I like to think of whatever that number out front, that a value, okay, think of it as multiplying by your height. Nope, I don't know why I did that. Okay, so it's multiplying by your height. So if I'm doing 2 times my height, okay, so think about it. If this is me right here, and if I'm doing 2 times my height, well, I'm now way up there. Okay, now I'm super, super skinny. Okay, I've gotten super skinny. But if I multiply my height by 1/2, so now if I take half my height, so now I'm down here, okay, what's going to happen to my weight? Okay, I didn't say I'd go down proportionally, right? If my height goes down, well, that's like smushing me and making me fatter. Okay, so think about the difference in the numbers. The number here made me taller. This number made me shorter. So what kind of numbers make me tall? Hopefully you said any value bigger than 1. And here you're saying any value less than 1. Okay, now again, we're not including a negative, right? That's why I did the absolute value of a, because what does the negative tell us? Do you remember? Let's go back. Negative flips it. Okay, so negative makes our graph go down. Okay, sorry, lost my train of thought. My sister walked in. Let's see, the negative on the outside makes it go down. Yes, flips down. All right, so now let's put it all together. Oop, too far. Okay, so here are all the translations, compressions, and stretches. Okay, so, oh, I didn't use the technical terms. Let me go over here. When we go here and we're making this skinnier, okay, the technical term is not skinnier. What we're going to do is call it a vertical stretch. Why is it called a vertical stretch? Because you are pulling on it vertically. So think about if you had a hand here and a hand here, you're pulling out, okay? Or kind of like zooming, okay, move your fingers towards that, okay? Here, so you're pulling them outwards. Here, we are smushing, so think about going down, okay? Think about like a weight pushing down on the graph, okay? That's called a vertical compression, okay? So when it gets fatter, it's a compression. When it gets skinnier, it's called a stretch. So again, here's all the technical ways to write it, okay? But essentially, if we have it on the outside, right, that's when we go up or down. When we have it on the inside, that's when we go right or left. When we have a number bigger than 1, it gets skinnier. And when we have a number less than 1, so between 0 and 1, it gets fatter. Okay? And then, of course, the negative on the outside is a reflection across the x-axis. Okay? Because again, we originally, the parent function looks like this, so the reflection is going to be down like this. Now, if we put a negative in the inside right next to x, that flips it across the y-axis. Well, think about your y-axis right here. So if we have a graph, let's say here, and I flip it that way, well, that doesn't really do anything. This line ends up on top of that line. So there is no, since it's symmetrical, there is really no need for the reflection in the y-axis. That negative doesn't really do anything. Okay? Not, well, only for absolute value. Only for absolute value. So we typically only say reflection in the x-axis. Okay? So let's look at some examples. Okay? So we can name the translations for these. Okay? So let's start with the outside. The outside tells us we are going to go up 1. The inside is going to tell us we either go left or right. This is negative, so it does the opposite of what we think. So it's going to go right 3. And then this number outside, it's a positive 2. So it is bigger than 1, so it's going to have a vertical stretch. All right, so let me show you this neat little trick. So I'm going to go up 1 from the origin, and then right 3, and end up here. Up 1, right 3, I end up here. And now I know it gets skinny. All right. I'm going to show you something really cool with this A value out front. All right, maybe you saw it, maybe you didn't, I'm not sure. But if you notice, we talked about it getting skinnier and fatter. Well, really, I adjusted those lines, and I adjusted the slope of those lines. All right, well, let's look at the slope of this line. That slope is 2. All right, what about this one? The slope of this line, up 1 over 2, that slope is 1/2. Notice the relationship between the numbers. All right, the number out front is the slope of the right side of the V. So this one is 2, so that means from our V we're going to go up 2, right 1, up 2, right 1. That's our right side. If we want to get our left side, we go up and left 2. Up 2, left 1, up 2, left 1. And now we have our absolute value function. If that made no sense at all to you, then by all means go back to what we always do and make a T-chart. Okay? When all else fails, use a T-chart. Okay? You can always do that. But this is a nice fun shortcut, so let me keep going with it. So here, we've got negative 3. That's a negative, so we're going to go down 3. Again, feel free to stop this and try any of these problems if you think you can do it. So here we've got plus 1, so that means we're going to go left 1. And then here we've got just a 1 out front, so there's no stretch, no compression. So let's graph it. We're going to go down 3 and left 1. We have no stretch or compression, so we're going to have a slope of 1. There's our right side, and then our left side. Alright, hopefully that made sense. If not, feel free to ask me in class. I'll be happy to do more examples of either shortcut or with the tables. Alright, good luck.